All right, this section is on polynomials, and we're going to do just some basics, and a lot of this is going to be kind of some rough drawings. So a polynomial is going to have many terms. That's what poly means, and it's always going to be in descending order. So your highest degree is going to come first, and then it should go down by 1 until you get to, this is a constant down here. Okay, so this particular graph there's some really cool ways to figure out its degree. So for instance, on this graph, I can count 1, 2, 3 like bends or loops, or like this is a valley and that's a hill, that's a valley. So this has 1, 2, 3 turns, which means this is a 4th degree polynomial. This one has 1, 2, 3, 4 turns, so that means this particular picture that they just threw on here is a 5th degree picture. So your polynomials always have to be written. The proper form is for the highest degree to come first. So what I think helps is to kind of have some basic pictures memorized. So if this is, and I'm just going to write y equals x, is linear, and y equals x squared is some sort of quadratic. Y equals x to the 3rd is some sort of cubic. And then y equals x to the 4th is going to be some sort of, it's going to have some characteristics that make it pretty recognizable. And we're going to talk about even and odds and a lot of different things. So then here's y equals x to the 5th. So that means there's 1, 2, 3, 4 types of bends, where this one had 1, 2, 3 bends. And so it's always one number higher. This x to the 3rd could have a little bend. It could have 2 bends in it. Okay, some of the other things that you would want to recognize would be, I'm going to do these right on top. So if this is linear and it was y equals x, like x to the 1st, if it happened to be y equals negative x, then it would be down. Okay, if this one happened to be y equals negative x squared, then the parabola would be opening down. If this happened to be y equals negative x to the 3rd, then it would be a little bit of like a reflection, like a mirror image. If this one happened to be y equals negative x to the 4th, it would be, ultimately, these would be going down. X to the 5th, you would have, if it was y equals negative x to the 5th, it would have the same number of bends, but this one is going to negative infinity and this one's going to positive infinity. So that helps us with the next concept. The leading term helps you to determine the direction of the graph. And what I mean by that is, like when we were looking at y equals x squared, that one was facing upward. In other words, this was going to positive, they were both going to positive infinity. But when it was negative, that's why I'm trying to use a different color, they were both going to negative infinity. So that tells you the direction. Another more mathematical term for that is end behavior. So the very leading term tells you the direction of the graph. Okay. Then the next thing that we're talking about are end behaviors. So when your highest degree, so the highest degree when it's an even number, then the end behaviors are going to be matching. Whoops. Help if I could spell that. So for instance, sorry about that, when it was x squared or when it was negative x squared. When it was x squared, both ends were going to positive infinity. When it was negative x squared, both ends were going to negative infinity. Okay, that's when it's an even number. So that would be any 2, 4, 6, 8, any even number as a power. Okay, if the highest degree is odd, then the end behaviors, oops, are opposite. Okay, so for example, if I had x to the third, that's some sort of cubic. So this one was going to negative infinity and this end's going to positive infinity. Negative x to the third, that means this end is going to positive infinity, this one's going to negative infinity. So that's for any odd number. So 3, 5, 7, 9, and this one was 2, 4, 6, 8, dot, 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 dot. So you just have to look at the degree and it'll help you determine the direction of the graph. Okay, so somehow the graph isn't with these same examples. So I'm going to pull the top off of 9 here. So if I look at this f of x graph and they tell me 11x to the third minus 6x squared plus x plus 3. I can look at this polynomial and I can determine a lot of things. Here's one super cool thing. That is a y-intercept. So I know 1, 2, 3 at, my graph's going to pass through 3. Okay, if it's a third degree, I know that it's going to be some sort of cubic function. There's some other things that I can determine, but I could, if I were in like a multiple choice situation. Oh, and here's another thing. This is 11x, that's a positive number. So I know that somehow this graph is going to have negative infinity on one tail and positive infinity on the other tail. So I could get pretty close to this graph with very little information. So if I were doing a multiple choice situation, I could get pretty close. Okay, so the next thing is this g of x graph. And it's negative 5x to the fourth. So right there, this negative is telling me that this graph is going to face downward. Okay, so I know things right there. And then with the fourth power, I know another thing. I know that this is an even number, so this is going to have matching end behaviors. I don't know why I can't spell today. Okay, let's see. And then the rest of the problem was negative 12x squared minus 2x plus 9. Okay, so the other thing I know is 9 is my y-intercept. I know the pink is running out. I use that a lot when I'm writing notes. Okay, so I know it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 is a y-intercept. I know it's going to be facing down. So I should know something like that. So the fourth degree also tells me that this could have 1, 2, 3 bends in the graph. Sorry, 1, 2, 3 bends. All right, let's look at the next thing. So the next one they gave me was, oh, this one's being really tricky. So I've got 3x squared, 6x, negative 4x to the 5th. Okay, so they're like really sneaking this one in on us. So you have to, in proper form, write these with the highest degree coming first. So this should be rewritten as, let me fold this down a little bit. H of x equals negative 4x to the 5th plus 3x squared plus 6x minus 1. Okay, so that's the proper form of this equation. They were just tricking you by starting off with 3x squared. So I know that this is a 5th degree, so this is an odd number. So here are some things that I can figure out. I know that I could have 4 bends in this picture. I know that it's going to be flipped from like the standard form. I know that with it being a 5, that my end behaviors are not going to match. And I know that my y-intercept is, is negative 1. Okay, so normally, like this is a 3rd degree, so normally on 5th powers, the left side of the graph is negative infinity, the right side of the graph is positive infinity. But this is negative, so it's going to do a flip. So I do know that I'm going to have some version of this side being up and this side being down with 4 bends. So I'm going to have like a lot of like snaking around on this graph. But it is going to go through negative 1. So a very, very, very rough graph. I mean, you could type it in the calculator, and I'm not perfect with this because there's other things when you're finding the zeros. I can get this more perfect, but this is like your first attempt at graphing this. So it's probably going to do something like that. So here's my 1, 2, 3, 4 bends. I don't know if this is correct. I just know that I've got a basic idea of what the graph would look like. Okay, so the last one on this page, actually they're giving this to us in a nice little form. But here's an x to the 1. This x is getting squared. So that means that's an x squared. So I have an x and I have an x squared, which means altogether that would be x to the 3rd. So this graph, without really writing it out that way, is a 3rd degree. So if this is a 3rd degree graph, 3rd degree, you could have 2 bends and it's going to have opposite behaviors. So there's a lot of things that I've opposite end behaviors. There's a lot of things that I figured out without like graphing it super precisely. Okay, then another nice thing that they've done for us is they've factored this for us. So when they are nice and they hand it to us in this form, I guess we should write a thank you note or something like super polite, because they have told us some great information. If I want to truly, like these graphs here were all just kind of me just stabbing at nothing. Like I don't know how precise this is, but I can get more precise with this graph because each one of these factors, this x plus 5, if I set it equal to 0, and this x plus 2, if I set it equal to 0, so if I subtract 5, that means x equals negative 5. What that is telling me is that's an x-intercept. So I can come over here on 1, 2, 3, 4, 5, and I know my graph's going to go through negative 5. If I come over here and I subtract 2, okay, I know that negative 2 is another one of my x-intercepts. Okay, so when I'm building this out, I have a great piece of information for us. Now, they didn't give me a constant term here at the end, but see that before times 5, oh, so it's going to be way up here somewhere. All right, so I can get really close. I know it's a third degree. I know it's positive. So I can get pretty close to graphing this because I know that that should be downward. Something like that. And here's another thing that I know. Because of this being squared, I know that that will touch at 2, but it won't pierce through like it pierced through at negative 5. And we'll get to that as we do some more graphing.